Now we're going to take up one more problem on the shaft. Problem number 20. It reads as, determine the ratio of power transmitted by a hollow shaft and a solid shaft when both have same weight, length, material, and speed. The diameter of the solid shaft is 150 mm and external diameter of hollow shaft is 250 mm. So it has asked once, it is in July 2007. So now we will take the data. D is 150 and D naught is 250 mm. And WH, capital WH will be equal to WS, and small LH will be equal to LS, and similarly capital GH will be equal to capital GS, then tau H will be equal to tau S, and small WH is equal to WS. So since he says small nh will be equal to small ns, the power transmitted. So that is, the weight is given by volume into specific weight of the material, which is area into length into specific weight of the material. So since both the shaft has same weight, so what happens? WH will be equal to WS. So that is AH into LH into WH will be equal to AS into small LH into small WS. As we know, AH is equal to AH. So what happens? Pi by 4 into D naught square minus DI square will be equal to pi d to the power of pi d square by 4. So pi by 4 and pi by 4 get cancels. Therefore, d naught square minus di square will be equal to d square. So substitute the values. 250 square minus di square will be equal to 150 square. Therefore, the inner diameter of the hollow shaft di will be equal to 200 mm. Now, what is the power transmitted by the shaft? Capital N will be equal to 2 pi nt by 60,000 kilowatt. As both the shafts have the same speed, power is proportional to the torque transmitted by the shaft. So the power transmitted by the hollow shaft divided by the power transmitted by the solid shaft will be equal to torque transmitted by the hollow shaft divided by the torque transmitted by the solid shaft. So that is NH by capital NH by capital NS will be equal to capital TH by capital TS. So you take TH is pi by 16 into tau H into D naught to the power of 4 minus DI to the power of 4 divided by D naught whole to the power of, whole thing is divided by pi by 16 into D cube into tau S. So you know tau H and tau S is the same and pi by 16 cancels. So D naught to the power of 4 taking the common factor in the numerator into 1 minus di by D naught whole to the power of 4 and close the bracket divided by D naught cube. D naught into D cube. So D naught, you can take this, you can rewrite the same expression in terms of D naught to the power of 4 into 1 minus di by D naught whole to the power of 4 divided by D naught. The entire thing is divided by D cube. So as tau H is equal to tau H. So taking the common factor of D naught to the power of D naught cube into 1 minus di by D naught whole to the power of 4, because D naught and this D naught and this D naught and this D naught, one gets cancelled. So it reduces to D naught cube into 1 minus di by D naught whole to the power of 4 by D cube. So substitute the values now, which is 250 cube into 1 minus 200 to the power of 4 by 250 to the power of 4. The entire thing is divided by 150 cube. So on further simplification, you will going to get it as 2.73%. Therefore, the power transmitted by the hollow shaft divided by the power transmitted by the solid shaft will have a ratio of 2.73. So this is how you will be able to solve this particular problem. Thank you.